We'll do the class. A program recursively copies files from an SVN server to a Linux server when an user commits changes. Write test cases. Do you all understand what is SVN mean? What is that?
Version control.
Subversion. Agreed? Version control tool. Just like GitHub, when you check in something, what does it do? It will copy the files. For example, there is a repository. Agreed? Let's assume that there is a repository in the SVN. So whenever you check in, it will copy from this one to, just like Jenkins does. This is actually continuous integration only. Yeah. So is this Apple question, Prashanti? Yes or no? Because Apple really does this. I know the app. I've been doing some Apple job helps. They really do this. They have their own tool to do this. Yeah. Okay. Now give me test cases.
First of all, the basic one, make some changes, commit it, and see whether the files are copied. Go in on the Linux
Okay.
server.
All right. Commit a file and make sure this is. How do you make sure this file is copied?
Go to the Linux server.
Okay. Go to the Linux. How will you make sure the file is copied?
Go to the directory structure where the files are usually saved.
Agreed. You saw the file, but how would you know that this file is modified? Last mod date time.
Okay.
Agreed. You see the last mod date time of the file, making sure that this is the new file. I got it. Agreed. So it will recursively copy. Am I right? So next, single file.
Try with multiple files. Yeah.
Multiple files. Next.
Try without making any changes. Update.
How will you commit when you don't make a change? You can't
Maybe
commit.
a comment, just adding a comment.
Okay, adding a comment is also changing a file. It's also changing a file. Agreed. File changed. We are not really looking at the code or functionality here. Anything else? Here, if you see, recursively means there might be a folder inside this, there is a file inside that, there is a folder, there is a file. You got it right?
Yes.
So change files at multiple levels. Multiple levels, on top level, child level, and everything. Make sure all the files are copied. Recursive files. Change a folder name or create a folder. Create a file. Agreed? Create a file, create a folder, create a folder. They should be, source control means not only changes, it is adding stuff too. Deleting stuff. Delete folder, delete file. Agreed? And what else we can do? Rename file. Yes, rename file. Okay. So all these things can be done. And not multiple roots at the root. Another thing is copies whenever a user commit changes. Linux server. It's a Linux server, right? Open the file on the Linux server and try to do the commit here. Did I make any sense? File permission denied. When you open it on the Linux server, this one is trying to copy. This one is trying to copy there. Agreed? Okay. So already it is opened. How can you replace that? So try to do a file permission issue. Agreed? File permission issue. And the other one is, for example, there are two types of copies. It is SCP, secure copy, because it is between server to server. If it is a secure copy, there are some things, read about this SCP command and what are the things which can go wrong with SCP, because if you don't make a secure connection to that server, it will fail. Other than that, SVN server, when a user commits changes. File permissions means look at the read, write, execute permissions on the files, verify them. Agreed? Because if I am checking in at what user and what is the user through which they are really updating, means finally even the SVN has to use a username to update the files and everything. Agreed? Remove that user, disable that user on that Linux server and try that. Agreed? And other than that, move that folder where that in the Linux server it gets copied to, move that folder to somewhere. Break it. Okay. Move destination folder.
Or rename that folder on the Linux server.
rename the folder. Anything else? Shut down the server. Yes, it is a test case. Shut down the server. Then what will it do? It will wait until it comes up and then copies, or it will copy will be failed. Got it, right? There might be, how is it done, asynchronous or synchronous? You can check that, if it is failing means we just lost that changes. Of course, it will, next time it will get everything, but we want to make sure. And
I mean the time frame in which the.
What do you mean by time frame?
It's
Two
we do any commit,
two people doing the check-in at the same time. Will it do merge or not? For example, in that file, I am changing the first line. You are also changing the first line. Which line I will get?
But which one is it?
That is in the SVN. I agree that, but is this changes going on? For example, I am changing the first line. You are changing the second line in the file. We both are checking in at the same time. Check-in went through. Check-in did not got blocked or anything, because it did auto merge or something like that. But is that merge coming there? So auto merge or anything? I think this is enough, more than enough. What do you say? Anything else? All right. So Java is a story. Java is a big story actually in software industry. As you all know that what happened in '95, before Java, application development. There are two things: software development, application development. Business applications are very popular, and Java came around the same time. Internet came. Internet and Java came at the same time, and the first usage of Java, everyone might have seen the applets, like playing a chess game within the browser window in Netscape Navigator or anything like that. So that is one of the applets became very popular, and Java really took off well with web applications. Java took off very well with the web applications. So it's like a good good merge of technologies around the same time. That is where actually Microsoft lagged all the time. They did not respect the internet much in the beginning, because they thought internet was one-time deal and it will go away. Agreed? So let's see what was application development before. There are many types of languages. Java is a application language, programming language, application development environment. It's a server environment. It's a deployment environment. It can be all of this. It's not just a programming language. But anyway, let's assume that it is a programming language. If it is, by looking at it as a programming language, what type of language it is? It's a high level language. C is a high level language. C++ is a high level language, and everything is a high level. So what did Java give new at that time when it came around? Java programming language cannot be proprietary. C is also open source. C++ is also open source. Smalltalk is also open source and everything. It is object oriented, but C++ was also object oriented. So let's see. There are two types of languages. One is called machine dependent. Another one is called machine independent. What does it mean? For example, if you look at go through platform dependent architecture, if you write a C program, if you compile that, you will get the operating system code. What is operating system code? It's an instruction set. It's a byte instruction set which is understood by that processor, that operating system only. Got it, right? If I have to talk to, for example, if I have to execute something on the Windows, everything finally convert into that interpreted language that is called OS code. So when you write a C program, when you write a C++ program, when you compile it, what will you get? You'll get an operating system level code. That is the reason when you write a C++ program or C program, you have to write differently for Mac, you have to write differently for Windows. For example, if I am building the PDF software for Mac and Windows, is it the same PDF software? No, why? The fonts are different, the styles are different, the windows are different, the color, many things are different. Why do you want to then still build two applications? Because I want to take the power of Mac for Mac Acrobat or Adobe Reader. I want to take the power of Windows for this one Windows. For example, I can I can use a window as an overlay or anything. There are different features and different things. Agreed? So that is the reason what I will do is, like, when I want to build a software, when I want to build a application which is useful or taking the power of that operating system, I will go for a machine dependent language. So if I have to develop a Microsoft Word software, should I use Java or should I use C++? Okay, if I have to use Notepad++, I want to build a Notepad++. Should I go for Java or should I go for C++? I should go for C++. Do you know why? The thing is, for example, Notepad shortcuts are there in Windows. Shortcuts are not there in Mac. Because I want to take the power of that operating system. Are the font system same on Mac and Windows? Are the features are same? For example, file operations, file save as, all these operations are same for Mac and Windows. Then why would I go for a common language which is common for everything? So will I go for machine dependent or machine independent? Dependent. I want a machine dependent. You might say that, but still the functionality is common. Like, for example, file new window, file saving a file, and whatever the text inside it is the same functionality. So you're telling that program is same but not the application. Understand, right? So a program can be reused. Like, I can write C functions and everything like that. I can reuse in multiple applications, but application is not same. Can I just compile the C program and run that Notepad Windows 1 on the Mac 1? Yes or no? Can I take the notepad.exe and run it on Mac 1? No. Why would I go for common one then? You got it right? Why would I go for common one then? Okay. So machine independent. So people think that just because machine independent is there, machine dependent is useless. No, machine dependent is more powerful, because you want to use the complete power of that machine. That's why you go for a machine dependent language. For example, if machine independent is popular, if Java is there, why is C and C++ are still existing? Because they are not, because they have something in it. Okay. So second thing is, there is object oriented and procedural. Object oriented and procedural. Object oriented means, so let's go for procedural. You have a C program. In the C program, do you have like classes? No. Everything you write is a function. For example, I want to write this Notepad software. I will say file new document function, save as function. I will write edit function. Everything is a function. For each operation there is a function for it. But you might say that one function can use another function. Yes. So when you write everything as set of functions, that is nothing but procedural. Procedural means everything is set of functions. Your software, your application is made up of set of functions. That is called procedural. Then why object-oriented programming? Object-oriented programming means it's a style, it's a pattern, it's a way to solve problems. For example, object-oriented is not only programming style, it's also analysis and design style. Analysis and design. For example, let's say I want to solve the banking problem. I want to write a software to use the banking and manage the accounts, bank accounts and everything like that. That is a problem I got. One way is create account, deposit, withdraw. I can write 10 functions and put it in one C file, .c file, or software.c file, and make a exe out of it, and I can use it. But the thing is, there is another way to write this. What are the entities inside that software which I just discussed?
Account number.
Account number is an attribute. Account type is an attribute. Which is the entity? Account is the entity. What are the other entities? Bank is the entity. Customer is the entity. Customer goes to the bank to create an account. In this statement, there are 3 entities. And what are the attributes for each entity? Account entity, account number, account balance, account type. What are the operations? Withdraw, deposit, check balance. For bank, what are the attributes?
Rate of interest.
Interest rate, saving interest rate.
Types of account.
types of accounts available, but that is enumeration, not part of this entity. Routing number, location, address, anything else? ATM available or not, or anything like that. Now, but you will still withdraw using account, not on this one. Agreed? And any operations on bank, get routing number. Agreed? Create a new account on this bank. Create new account is not on the account class, it will be in the bank.
Number of customers in the bank.
Number of get total number of customers, that is in the account, because you are doing from current account to other account. Agreed? That is bank. Customer ID, name, SSN, address, change, get details or anything like that. That is about customer. Account balance is on account. Customer can have multiple accounts. Account array is in the customer. Agreed? So in other words, when you write software like this, it is called object oriented programming. So you will not directly write create account. You will write customer class. You will write account class. You will write withdraw in the account class. That means you define entities. You define operations on them, and interaction between entities is nothing but business. Customer goes to bank to create an account. So a customer has to create a new account and then do transfer, deposit and everything like that. So when you translate these entities interactions into programming, that is nothing but object oriented programming. Object oriented programming is nothing but a entity is represented as a class in programming. So you write classes. So now let me ask you, how many object oriented programming languages you know? C++, Java, Python. There is object oriented too, but I think it's more scripting or more procedure. Ruby, yes, Ruby is scripting, but also C sharp, yes, you are right. C sharp is object oriented. .NET is a framework, it's not language. VB.NET is a language. VB.NET is object oriented. Procedural. Anything else? VB script, Perl, Python, shell scripting. Agreed? So these are all procedural. Machine dependent. C, C++. Anything else? Small talk. Not small talk. I think it is any other old programming languages are mostly machine dependent. COBOL and all this, but I don't think I should mention COBOL here. Okay. Machine independent. Java. Anything else? C sharp is Microsoft machine independent. That means for them only Microsoft machines are machines. For them Unix is not a machine. Okay. That means Windows 8, Windows 9, Windows 10, Windows, for them that is the C sharp will run on all Windows machines. I'm just kidding, but that is true. So anything else? Perl, Python are also machine independent. If you have that runtime or the interpreter for them, you can convert them into anything. Even mostly Perl and Python, because we have interpreters for them for Windows and all operating systems. The third type of classification for languages is one second. Scripting versus compile time. Yeah, I'm very sorry about this. Actually, I am coding in JavaScript, C sharp, and Java at the same time. Okay, so sorry about that. Okay, so coming back, there are two types of languages. One is called scripting languages, and another one is compile time languages. What is the difference between scripting language and a compile time language? Shell script, VB script is a scripting language. JavaScript is a scripting language. It is object based language. I agree that, but still it is a scripting language. And C sharp, Java, C, C++ are all compile languages. Can anyone tell me why they are called scripting languages, why they are called the compiled languages? Which one is more powerful? Compiled. Why? Because you check for the errors before and you compile it and you have an execution piece so that you want to execute that. There might be still runtime errors, but you will not have compile time errors anymore. The thing is, scripting languages are created for getting small tasks done. For example, like let's say I want to move every day. If I drop a file like .java file here, I want to move this automatically from here to here. Let's say if anyone is dropping onto this desktop .java file, automatically the program should look at it and move this to this folder inside this to notes or anything. It is a small automation task. Automation means not test automation. Okay, small automation. Any automation you want to do on a machine, use a scripting language. Because I want to move this, for example, I want to create a cron job. Daily night send an email to someone. Is this a huge application? Is this a software I'm building? No, getting small task done. It's a task runner, task or a script or a small execution to get something done. This is called, so we use scripting languages for them. But why do we have so many scripting languages? For example, for Unix, we need a scripting language which can understand the Unix shell. For example, if you want to get all the list of all the files, what will you do? ls-l. But if you want to move files or anything like that, MB or anything like that, you'll use some commands. If you want to use secure copy or anything, you'll use SCP. But I want to do this automatically. What will I do? I will create a shell script. I will put logic in it. I will write a for loop or something, and maybe I will give parameters based upon that. I can schedule it for the cron job or anything to run on the task manager to run it on a schedule basis. So what am I trying to do? Scripting languages help us on their environment, the environment they are running, to do some automation or to get some tasks or jobs run. There can be shell scripting, there can be VB scripting, there can be PowerShell, that can be even JavaScript in the browser, inside the browser to manipulate the DOM or anything like that. These are all the scripting languages. But the thing is, you write the program and you run it, you don't compile them. So if you have any errors or anything, it will break it. Fine, because we are okay with that. But compiled languages, you make an executable code, which is operating system code, which is ready for the operating system to run it. Agree? So scripting languages are also called as interpreted languages. A interpreted language is a language where this conversion is happening while the program is running. In compile time languages, the conversion happened while it is at rest only. So you compile, then you run it. For example, I want to make a PDF software or anything. I compile and I make a Adobe Reader.exe or something. It's already Windows code. When I double click it, it will launch it. I'm not compiling, I'm running it. But for scripting language, when I write a JavaScript or a VB script or anything, I have the file directly. And other thing is, you get the code. You directly run the code. You have to have the code. There is no compilation or anything. So code is visible and everything. So you don't do it for application purposes. But recently things are changing. People are building more applications on JavaScript now, even on server side and client side too. But you might say that then you have to give the code to the everyone. But are we writing any standalone applications anymore? Or is it a software as a service or a service oriented architecture or anything? So will we give them code anymore, or is it they have to just call our server and get the information done? Okay, so that's one. Okay, it really doesn't make nowadays whether we are giving the code or not, but are you compiling during the runtime or are you compiling before the runtime matters. But really, like you might say that you may not use a shell script to build an application. But olden days, like CGI scripts, when they used to build web applications, they used to use CGI scripts. There is nothing but using shell scripting for making web application. So people are moving from scripting languages to compile languages for enterprise applications, huge applications. But nowadays, for few things, small things, like for example, if you want to build a chat server, you'll go for a JavaScript language with a Node.js framework rather than Java. Okay, so that is another thing which we will talk later. Okay, so but the thing is, scripting languages are not very powerful, I would say, at least in the enterprise level for enterprise applications, except JavaScript. Okay, that is special. So we have three types of classifications. Languages can be classified as machine dependent and machine independent. And machine dependent languages, you are writing software for the particular operating system application based upon the particular operating system capabilities. You want to take advantage of that. And then we have like object oriented procedural, the way of style of writing the code. Which one do you think better? And whether you want to go for compiled or scripting, depending upon what type of application, how much stability you want in that application. Like, you compile and you don't care about the components or anything like that. You want to build components or anything like that. Now, for business applications, do we need a machine dependent language? For example, I open a browser and I go to bankofamerica.com. Does it really matter to me whether it is made in C++, C, Java, .NET or anything? Because anyway, I'm using just web browser. I'm not installing anything. I'm not taking the power of machine. So should I go for a machine dependent or machine independent? Machine independent, because I don't have to worry about what is your machine or anything like that. So I will go for machine independent language. When I'm writing a business application, should I go for procedural or object oriented, which is more readable, which is more reusable, which is more more way to make relationships of the business? Simple, entities. Business is all about entities. If I am going for a enterprise application, enterprise business application, should I go for scripting languages where I run the application, Bank of America application, still I have errors. I'm just now, I don't compile or anything like that. Now my user is finding compile time errors or anything like that. Which one I should go for, compile or scripting? Yeah, I gave a bad example. I take that back because JavaScript is an exception. Except JavaScript, that is true. Okay, but using JavaScript we can do anything. All right. So Java is machine independent, object oriented, and compile time language. But you might say that C++ is machine dependent, object oriented, and compile time. C, machine dependent, procedural, and compile time. So Java is the one which actually filled that gap, and that gap is actually, there is another language called Smalltalk, which was created before Java, and the company which created it was Xerox, and they created Smalltalk and some other languages. And Smalltalk actually created a framework or this design where they can use two things. One thing is a language. For example, if I write a machine independent program, if I write a machine, how do you achieve machine independence? When you compile, you have to get something. Agreed? You want to have a compile language, you want to still have machine independence. For example, if I am using a scripting language like Java or VB script or anything, I might say that this scripting language is supported by all of them. For example, Apple script is supported by Apple machines, and VB script is supported by Windows machines. Shell script is supported by Unix machine. But we can take Perl language. It is supported by all the operating system. We can create a runtime and say that we create application for all the operating systems. But it is not compiled, it is scripting. So you see the code. How can you make a compiled language but still which is machine independent?
By converting into intermediate code like Python.
That is what. So there is two-step process. What generally happens is, first you have to create a runtime engine. This runtime engine will understand a code which is not Smalltalk, which is not Java or anything. For example, Xerox did this first time. So runtime engine will understand a code, but that is not Smalltalk. For example, Perl interpreter will understand Perl. JavaScript interpreter will understand JavaScript, and C++ Windows machine will understand the exe compiled. But here this one will understand a intermediate language, IL, intermediate language. Then how will you get this intermediate language? You compile Smalltalk and you will get IL, and when you run the IL, it will run on this runtime engine. So you have two languages? Yes, we have two languages. So it's a two-step process. You compile, you get something intermediate, and then you run it, it is there. So is it compiled or scripting? Both. It's Smalltalk is compiled, but the intermediate code which is coming from it is interpreted. So the environment itself, so the Smalltalk environment is combined of both, compiled and interpreted. Agreed? So similarly, this for Java, this runtime engine is called Java runtime engine.
Yeah.
Okay, yeah, I agree. That conversion is different, and this IL is called bytecode, and this language is called Java, and this compiler is called Java C or Java compiler, and this runtime engine you invoke by Java. Same thing. So this actually, the architecture of Java came from Smalltalk. The code, the syntax, the style at which you write the language came from C++. So then what did actually Java give more? Java, really, can you not hear me? Everyone online, can you hear me? Is my voice breaking? Okay, Rama, it is at your end. All right. So the semantics belong to Smalltalk. The syntax belongs to C++. But what did Java do more? There is more. Java simplified object-oriented programming. Means, for example, if you are a C++ developer, there is multiple inheritance. There is, a pointer. There are other things. So Java took out everything and made it simplified. So it is not, Java is a powerful language. Java is a smart language. Okay, it simplified it. So Java simplified C++ and still it is being object oriented. So it did not lose that object orientedness because of the simplification. So it still stick to object oriented and try to simplify it. And the next thing is, Java came back with a huge set of libraries. For example, I want to do function, sign function. I want to read a file. You don't have to write everything. It will come with libraries so that they are ready to use, like utils, properties, hash map, collections, everything. It will come with arrays, strings, and everything like that. So it came up with a huge library. Okay, huge library. And the other thing is, it came up with the J2E framework to build applications like web applications, applets, and everything like that. It came up with the framework to do that. So, and also it came up with many tools. Like, for example, I want to do documentation, I want to do packaging, I want to do so many other things. So it came up with so many tools, so which simplified the job of the developer. So they went for that. And another thing it simplified is garbage collection. So one of the other things, which Java took control from the developer and said that I will take care of this, is garbage collection. So as Java is simplified, people and application, it suits very well for application development. People started using Java for application development. At the same time, web took off and web applications became popular. People used to use CGI scripting, and as people thought that CGI scripting was bad, and they went for JSP servlets kind of application. So many enterprise web applications. So you can build not only web application, you can build a applet, you can build a console application, you can build a desktop application, you can build a web application, you can build a website, you can build, but don't do build website with Java, because that is too much overkill. Because if there is static HTML, you can build a web service, you can build a server like Tomcat or anything like that. You can build a backend process like a service or batch processing or anything like that. You can even build editors and everything like this, means like IDEs or anything. So using Java you can do anything, pretty much everything. Agreed? So you can build every type of application using Java. Agreed? But mostly it was used for web applications and services and everything. Okay. Any questions as of now? All right. And James Gosling is credited for creating this language. Actually, he wanted to make a programming language for home appliances. So he did not like C++. So he ended up creating his own programming language. And he was sitting in somewhere in near Berkeley or somewhere. He was sitting uh, in a cubicle which is next to a window which has a oak tree outside it. So that's why it is called oak name. Then they thought about renaming it, and they were drinking coffee made by beans, came from Java Island near Indonesia. They came it Java. Agree? And JavaScript is different. Java is different. The only thing is Netscape company created the browser, first browser, Netscape Navigator, and it is shaking up Microsoft. And this both Netscape and Sun Microsystems are in Bay Area. They don't like Seattle much, okay, because their competitor is there, Microsoft. They want to actually kill Microsoft, so they partnered each other. So at the same time, Netscape Navigator is trying to build a programming language in the browser to do some automation like alert boxes, clicking mouse over, some color changes and everything. You want events, right? Browser events and everything like that. So they were creating, some guy Brendan Ike was creating that language. He did that in 1 week or 2 weeks, JavaScript. So he took some concepts from Java, because the developers from Sun Microsystem went and helped him actually, but he did it by himself mostly. So that's why it is named JavaScript. Their partnership made it JavaScript because they wanted to use this trademark Java, and as Java should take more over than Microsoft, that's what their intention was. But you don't know what happened to Netscape after that. Okay, yeah, and what happened to Internet Explorer after that. Okay, all right. So let's write a small program, and another thing is, by default Java is open source. Sun Microsystem made it open source, and Java you can just download it and you can install it. So when you install, you have JRE. You need to have JRE to run Java programs. That can be whatever the program. If there is Java, when you compile, you will get the interpreted or intermediate language, and that compiled code will only run on JRE. It will not run on anywhere. But you might say that, so I have to install JRE. Yes, there are 3 billion devices where JRE is already installed. So that means pretty much everywhere. Agreed? Except your Apple devices. Okay, so Java is almost everywhere except your Apple devices, but they too take millions now. So you can say the number of percentage is less. Anyway, JavaScript is the most used language, not Java. In every machine, JavaScript is there, but not doesn't mean Java is there. Okay, all right. So coming back to install JRE, automatically many people will have JRE. Why? For example, Firefox. When you are installing Firefox might have dependency on JRE. So Firefox will first install JRE and then will install Firefox itself. So any dependency software management will be done, dependency will be downloaded, and then it will be installed. So you might have a JRE. But the thing is, we are not here to run Java, we are here to write Java. And you have to compile Java. So to run a intermediate code or the bytecode, you need runtime engine. But to write the Java program and compile it, you need Java development kit. So that is why JRE is separate and JDK is separate, because JDK is development and JRE is running. But if you do development, don't you run it? So JRE is also combined into JDK. There are multiple versions of JDK, and what is the latest version? 1.8 or 1.9? 1.8, I believe. Okay. So where do you see this? You can go to see program files, Java and JDK. You can see that 1.8, 1.7. And if you go into JDK, you will see JRE even inside this, because this is 1.8 JRE. But you can sometimes, you have JRE outside also, but that is okay. Okay. Then there is, in this JDK, you have JRE and there is a bin. In this bin, all these tools are there. Remember, Java is meant for all operating systems. It is not meant for Windows application. So that means, like, when you double click it, don't expect it to open and show you something nicely and telling you what to do, click here, click there, or anything. No, everything is a command line tool. You have to using command line. If for Windows you have to use command line, for Unix you have to use the shell and everything like that. So they don't open up, or then, but these are all tools. And if you see, there is a Java C, that is the compiler, and then there is Java. This is the runtime engine. Java is the runtime engine, and Java C is the compiler for JDK. But the thing is, when you install this JDK, so let me ask you, Java is compiled and interpreted. You compile it, you get an intermediate language. Okay, so if you write a Java code, it will run everywhere. Write once, run anywhere, because it is machine independent. But it will run everywhere there is a JRE. Agreed? It will run everywhere there is a JRE. Is JRE built using Java? If JRE is built using Java, so then when you compile JRE, you should need another JRE to run it, right? Agree? JRE is not built using it. What language do you think it is built? C or C++? Agree? So then is compiler built using Java?
Yes.
Compiler is built using Java because it has JRE. It does not need another JRE. Agree? So in Java, runtime engine is not Java because it cannot be Java first of all because it cannot need another runtime engine. Agree? So remember that. All right. So now when you have this JDK, when you install, you cannot directly go and use on a Windows machine. Why? During the end of 90s, Microsoft and Sun Microsystem fought. The reason is they created a JVM. JVM license is given to everyone, so everyone can create their own JVM. And some big companies created their own virtual machines. When Microsoft did that, it did not follow some rule or guideline. So Sun Microsystem sued Microsoft, and Microsoft got upset and said that I will not support Java by default. So what do you have to do every time when you do this? If you want to go and use using command line, when you go to command line, and if you want to use Java C or anything like that, by default Windows will not recognize it. For me it is recognizing because I have already set it up. So you have to go to environment variables. Agreed. You have to go to system environment variables, and you have to go to this environment variables and go to path and edit. At the end of this, put a semicolon and copy this thing, telling that whenever I type something in the command line, look at all these folders including these folders too, and restart the command line. Don't forget to restart the command line because it has to set the path variables from the scratch. And when you do this Java C, you will get like this. So if you see Java C, and you can say version 1.6 we are using by default because I set the path to 1.6 version. If I go and remove that path and set it to 1.8, it will use 1.8 version. And this is the Java. My command line is using Java C from 1.6 folder, but I have 1.6, 1.7, 1.8. You can have multiple versions of Java. Agreed? Next thing is, let me write a Java program. To write a Java program, you don't need anything. You can write it from anywhere, even on a Unix machine. I will write a Java program. Java is a case sensitive programming language. If you put public with capital P, it will not run. Agreed? Case sensitive. And Java is an object oriented programming language. So that means every file starts with class. Every file will contain a class. Whether it is public or not, we don't have to worry about that, and it will have a class. And the class name, there is this class and class name. Class name takes a casing of Pascal casing. Pascal casing means if you have like bank account, how many words are there?
Sure.
Every word first letter should be capital. That is called Pascal case. Hello world, how many words are there? 2. You cannot write a sentence here, hello space word. Class name should be one word. But inside that meaning, there might be other words in it combined together, but it cannot be spaces or anything like that. Then you will write a method, public static void main and string args. So you can see string S is capital. Okay. And I am writing system dot println and for strings it takes double quotes, it will not take single quotes. Okay, so this is how you write a hello world. And if I write a text file, it will be dot text. If I write a PDF file, it will be dot PDF. If I write a Java file, what will be the extension? Dot Java. Simple. File save as, not save, and I will say all types, and I will go to C folder, applications or training, and I will write my hello world.java here. Okay, I got this because notepad gives syntax highlight and everything, that is fine. So if I go to C training applications, or okay, so this is my file. I just saved it 8/17/738. Okay, you can see. Now if I go here, I will change the directory to the directory C up training, right? I'm in that C training folder. How do you compile a Java program? Remember, write Java program, then you compile. How do you do that? Java C hello world.java. So you can see there is a dot class file created. This is also, you can call it as a class file, you can call it as a bytecode, or you can call it as an intermediate language. So when you right click and open it, it looks like garbage. Okay, so that is how it should be. Okay, and now I will delete this file hello world.java. Okay, I will just delete this. Do we have source code anymore? This is called source code, that is called binary code. Generally in C program or anything, C is the source code and the binary code is the Windows code. But here Java is the source code, binary code is not really binary, it is intermediate code. Binary code will be generated at the runtime. Now if I have to run this, can you show me? Yes, I save, we wrote it in the notepad. I am saving this as in the going and saving it as hello world.java. Save this as a hello world.java inside any folder. Now go to that folder again. Go to that folder in the command line and say Java C. You can directly give the path like training hello world.java. But I don't have that file anymore, so it will fail. Okay. That will compile and that will create the dot class file, dot or bytecode or intermediate code. How do you run a Java program? Remember, there is a Java, just Java runtime engine, and you will say hello world. You will not give dot class. Why? The file will contain only one class. You have to give the class name, not the file name. That is why in Java you have to use the file name and the class name as same. Hello world.java should contain a hello world class. Agree? So when I type this, what did I get? Hello world. So I will repeat this again. We using a slide. Okay. So this is a typical C program. If you look at this, you write the code, and then you compile. That is like checking for errors, checking for syntax, and checking for like type safety and everything like that. So that is checking for the errors here, that is compilation. And when you compile, this is a big process comparing to Eclipse. Yes, I agree. But you should still know how Java does it. If you don't know, then how do you know what is Eclipse doing behind the scenes? This is for our understanding. See, everything cannot be just to directly use stuff, because if your understanding is not good, if an error happens or something issue happens, how would you know where it is going wrong? That is only. So don't take this class very seriously. This is more for you to introducing you to Java rather than making you run away from Java. Okay. Yeah. So once you compile, you got the binary, that is zeros and ones and everything like that, zeros and ones and everything like that, and you directly run that. This is C program, because you compile for, so in a C program you compile for Windows, you compile for Mac, you compile for Unix or anything like that. Here you don't have different compile stuff. In this is JavaScript, this is not Java either. If you write a C JavaScript or VB script or anything, you write the program, then run it directly. The interpreter is converting them into binary at the runtime. When you write a VB script or JavaScript or anything, the interpreter sitting into that operating system or that browser or anything is doing that conversion and everything like that. How does Java run this? Java has already JVM installed onto their machine. Before I said JRE, now I am saying JVM. I will show you the difference. But in other words, JRE contains JVM. You can say that JRE is a big thing, inside the small thing is a JVM. So let's assume that it is JRE for now. So you have JRE on each machine. That might be Windows, that might be Mac or anything. Is JRE different software for different machines? Yes, agreed. But every JRE is also created by Sun Microsystem. Java is also created by Sun Microsystem. Compiler is also created by Sun Microsystem. But nowadays Sun Microsystem is not creating it. Who is creating it? Oracle. Yeah. Alright. So when you write a Java program, you compile, you check for errors and you compile. You will not get binary code, you will get a byte code. Byte code is the intermediate code, the dot class file which came. Now then when you click it or means when you run it, that is getting converted into binary code using the JRE. Agreed? So that is what is happening. So how can you say this is machine independent? I can take this class file and run it on Windows, Mac, Linux or anywhere you want, as long as there is JRE installed. Mostly it might be installed already because some program on it is already using JRE. For example, Tomcat has JRE, some any machine might have JRE already. So more or less I can run this on any machine. Agree? So that is what Java runtime engine is. Are we clear on this? Okay. There are three things which we have to remember when it comes to Java. Java runtime engine, Java virtual machine, JDK and API. Okay, what is that? JDK is the development kit. It is like it will contain tools like compiler, Javadoc, jar, packaging or some other things. Or JConsole, JProbe or anything like that, because it will check the performance, to check what is going on behind the scenes and everything like that. JRE is a runtime engine. JRE contains many components and JVM is one of them. JVM is the real interpreter which converts the byte code to machine code. But with JVM, can you do everything? No. You need JRE. You need many other things. For example, you need garbage collector. You need class loader. You need bytecode verifier. You need some other tools like check managing the heap or something like that. Agreed? So you need much more than just JVM. JVM is the pure converter, interpreter between the bytecode to the machine language. Okay. What is API then? API means the programs which Java supplies ready-made for you. That is API. Okay. Okay. So JRE, JVM. Okay. There are four things JRE environment takes care. So let me show that in a slide. See, this is called compilation time, compile time. This is called runtime. There will be two types of errors: compile errors, compile time errors, and runtime errors. Compile time error means syntax error, type safety errors, or type mismatch errors, or something like that. That means you did not even produce the bytecode yet. Once you produce the bytecode, when you are running the program is executing. Something might go wrong in the memory. That is runtime error. Agree? So runtime error will happen here. So compile time is writing the Java code, doing Javac and getting .class files. Is there much more to it? Nothing. It's very simple, straightforward process. Conversion, it's nothing but converting from one language to another language. Like Google Translator, go to English to some other language, it's nothing but converting to that language. But you might say that, is this bytecode language like a secret language or anything? No, it's open. Anyone can write bytecode language too. But then what is the purpose of it? Agreed? For example, now there is one thing I would like to discuss. For example, why should I do compilation? Why can't I directly write bytecode? it's not really human readable. It's like closer to machine but not machine. It's closer to machine or assembly language, but it is not really assembly language. Okay, so in other words, for example, if I write a Java file with 10 KB, will I get 10 KB bytecode file? No, I might get 12 or 13 KB file. Why? Is that language too complex? No, it is more or less the same thing. Then why do I get 13 KB file? What is that? Metadata. Okay, there is something called metadata. When Java compiles, it will compile. It will do the conversion from Java to machine code. For example, if you look at this Java code here, let me copy and paste this here. You need this. It will go and convert this line into machine byte code. It will go and write this into byte code. It will go and write this into byte code. Other than doing that, it will say that I am compiling using 1.6 compiler. Okay, I am compiled on a Windows machine or whatever it is. I think it will put that information too, and it will say that there is one class here called hello world. There is one method called main method, and which takes string arguments, string array arguments. Then there is one line inside that method called system.out.println, and this is called metadata. Why? Data about data. Just like all underscore tables, all underscore objects, all underscore columns in Oracle. Did you learn that? Metadata tables. If I say select star from E, automatically my IntelliSense will show EMP employees automatically. Why? How? Because the editor will go and search in the select star from all tables, all underscore columns, all underscore objects. Oracle has that metadata tables. Every database has metadata tables which have data about data. What are all my tables? What are all my columns? What are all my objects? What are all my triggers? Alright, anyway, similarly, it will write the metadata. It will encrypt it. It will encrypt it with a private public key. Agreed? It will encrypt with a private key, and every Java version will have a private public key pair. Now, when the JRE is running, that will have the private public key to combination to open that. So only people who can read the metadata is who get that key to read that. Even other people can do that. For example, Eclipse. When you automatically say system dot, it will give all that messages. How it is giving? Because it is reading the metadata. So you can use this metadata for IntelliSense. You can use this metadata for verifications. You can use this metadata for security and other things. So bytecode is a combination of metadata plus data. Java program plus the metadata about the Java program. Now, once you have this, so that is what compilation is. During the runtime, there are 4 steps which Java takes do while doing the runtime. While you run that Java program or any bytecode program, the first thing it does is called class loading. Second thing is called bytecode verification. Third one is just-in-time compilation, and fourth one is, actually you don't have to discuss about this fourth one, but anyway, as we have time, we can discuss. Okay, all right. Class loading. For example, remember, I opened a PDF file here. Assume that it is on my desktop. Until I double click and open it, will it open? What does opening mean then? Is it loading into memory so that again a viewer can view with me? Similarly, a dot class file, if you want to run it, someone has to load that into memory. But you might say that what is special? Every programming language does that. Even C has to load all the binary, and C++ has to load all the binary. What is special about this class loading? It is not Java loading, it is class loading. That means it can load single class at a time. And 10 classes can come from this machine, 10 classes can come from other machine, 10 classes can come from internet, 10 classes come from somewhere else. It can combine all together in the memory and say that it looks like one application. What does it mean? It can load classes from disparate sources. So that's why class loader is very popular at that time. Nowadays, no one, every framework does that. Okay. So class loader is not like loading whatever is in the local machine and loading it into the memory. It can load from many different sources and load it into memory. Second thing, so that is why class loading is a special thing. So you have to load that into memory because you have to then compile this into using JVM into machine code. But before compilation, you will see for every class file, the metadata is equal to data. That means, for example, if anyone might have changed the code in between, for example, I compiled and I got the byte code. But while I'm sending it to you, someone came in between and changed the byte code and wrote something like, which will say that system.exit, system.corrupt, system. There are no such methods. I'm just making it up. Okay. So they are making some methods like this and they are going to corrupt your machine or anything like that. Why would I let you? That is why before running this code, we want to check that the metadata is in compliance with the data. If metadata and data are not consistent, what will Java do? It will stop running that application. It will stop that. So that part is called bytecode verification. Bytecode verification. Once the bytecode verification is done, it will not convert all the class files into machine code. It will not do that. The problem is if it does it, it will become slow. Because when you compare to a C program, C++ program, they just wrote the binary and everything is already compiled, they are running it. Now we are compiling, we are verifying, we are doing all this, it will become slow. That is the reason just-in-time compilation. If there are 1000 class files, it will not convert them into binary directly. It will take as needed. That's why it will know first class. What is that? Hello world class. And then you might call another class. Then you might call another class. So just in time, whenever you call a new class first time, it will go and get that and it will compile that into binary. Until then, it will not do that. But it will verify the bytecode. It will do the class loading, but it will not compile. And the program is running. As the program is running, many objects are being created in the memory. In C++ program, it is the developer's responsibility to create an object and also to dispose an object to free up the memory which is not needed. In Java, you don't have to do that. Whenever there is less memory, a program automatically kicks off and it will clean up the garbage. So what is garbage? How to clean up that garbage? We will see that. There is an algorithm called mark and sweep. Go and mark the garbage, then come and sweep it again. First go and check all the garbage and mark it. This is garbage and everything, and come do a second pass and delete all the garbage. That is garbage collection process. So go ahead. It will only come when the memory is low. I'm just putting it as a fourth point here, but really it is not part of every runtime. Garbage collection will not run if you have enough memory and if you don't. And when I say memory, not your RAM memory, your Java runtime engine process memory. It needs heap memory, okay, which we will talk later. So don't see this as a separate item. Don't look at it as part of the runtime. So JRE has three tasks: load, verify, execute, and clean as you go. Clean means remove the garbage. As you know that writing code in Notepad is very complex and everything like that. That's why we need editors. Editors which can integrate all these development tools like JDK, JRE, Java C and all this, which can integrate all of this and give us one package where it is ready to execute and ready to run these things. Agreed? That is why we call them integrated development environments. And some of the popular integrated development environments are Eclipse, IntelliJ, NetBeans, JDeveloper, I don't know if it is still there, Visual Studio for other things, WebStorm, and there are many things. But we will use IntelliJ actually. Sorry, we will use Eclipse, but I'm planning to move to IntelliJ soon because I'm doing that automation project in IntelliJ. But it's up to you. You want IntelliJ or Eclipse? IntelliJ. Okay, we'll go for IntelliJ. Yeah. So you can go for IntelliJ. Okay. So it really, there are not much differences. You can write in anything, but the only thing is we want to check in the code directly. You can use egit plugin here, or you can use IntelliJ git plugin or something there. Okay, either way. So what does this environment do? This environment will combine everything. It's like one place to do everything rather than going into shifting between notepad and command line and everything like that. But there are other features too. Eclipse is one of the very powerful software. It is a plugin based software. Eclipse has so many plugins that you can do more or less everything. You can do SOAP UI here. For example, whenever you open a Eclipse, you will get two things. One is called perspective, another one is called view. Eclipse is not only meant for doing Java. Eclipse is meant for doing PHP, C++, C, XML, database, everything, even JavaScript too. How do you change the Eclipse, the face of it, to do something else? By changing the perspective. Perspective means a type of structure of design or development. For example, you can do Maven, you can do Ant, you can do some other thing. So when you say open perspective, by default it is Java, because we installed Eclipse for Java. You can say that I want a SOAP UI perspective. Automatically it will convert itself into a SOAP UI tool. Agreed? You can see that. Now I can say new WSDL or new project, and you give the WSDL or anything like that. Let me go here and do that. New SOAP UI project, give the new WSDL and everything like that. So Eclipse is a very powerful plugin based architecture tool. Okay, but we will go to the Java perspective. We are not doing SOAP UI here, and in that there is something called view. View is nothing but a window or the widget here, so we can hide package explorer. I want to close this, or I want to open it again. Go and say view. View is like the number of windows available in that perspective. Agree? So whenever you open Eclipse for the first time, you have to set the workspace. Workspace is nothing but the main root directory where all your development will go. Whenever you create a project in Eclipse or IntelliJ, it will divide into two folders, source and bin. Source means .java files, bin means .class files, bin means binary. Agree? So, and if you go to package explorer or anything, create a project either way. Like I will create a new project. In this is IntelliJ. Eclipse is free, IntelliJ is not free. If you have a student email or something, IntelliJ is free. Okay, so that is one thing I understand. Okay, just say Java, Java E, whatever it is. Okay.
So when there is Eclipse, why will people use IntelliJ when it's not free?
Because some people like IntelliJ type of tools. IntelliJ is a good tool because the font, coloring, style, windows, and everything. People feel it, and they have a lot of plugins, integration plugins, and everything like that. Eclipse, it's free, so less development nowadays and everything like that. But Eclipse is a powerful tool. Most used is Eclipse, but companies want integration with Subversion, integration with Git, integration with which one is better, they will go for that. For example, my company is using Git plus TeamCity or anything to work. For example, my work is in Jira, my source control is in Git, my let's say continuous integration is using Jenkins or anything. I can get all the plugins for this here. So I can connect to my Jira work item, I can connect to all, I can do together. So whichever integrates all my tools is better for me rather than which is separate. You got it right? But it is not really pricey.
You have the same plugins for Eclipse as well.
Yes, but plugins are not very usable sometimes because it's someone else is developing it. Here mostly IntelliJ is developing. I mean JetBrains is developing it, and JetBrains has a suite of tools. I like their WebStorm a lot. For JavaScript, they have the best editor for JavaScript. If you go for for example, if you are a .NET developer or C# developer, they have the best plugin for code analysis, ReSharper, most used plugin in Visual Studio ever. So if you go to JetBrains, they have some good tools. You will know why. If you are used to JetBrains style of coding, you will never like Eclipse. If you really like Eclipse, you will never pay for anything. You got it right? So it's two sides, So, but JetBrains has like, different tools like, let me show the products. RubyMine is one of the best Ruby editor. and WebStorm JavaScript editor, PHP app code. ReSharper is the .NET plugin. .trace is checking the performance of a .NET application. TeamCity is the continuous integration server like Jenkins. UTrack is like a tracking, bug tracking, Jira or Bugzilla, and I don't know upsource, maybe the source control, but I know only few of this. Okay. App code is for iOS development. Okay. Python, I have used only PHP Storm, WebStorm, IntelliJ, and I used ReSharper and little bit of TeamCity. They are very popular for tools, and they are cheap pricing. They have like $150 per year for license or anything. It's not like a huge software they are trying to sell. They're more open source oriented only, but they are they're cheap but not free. Agree? I will say command line app, and I will say the project name is okay. You can see, like I can say, 1 second. I can say view. Okay, I have the project here, and I have source here. I can see there is a main file. The reason is we don't have a SDK. Setup SDK, configure SDK, and I'm going to see program files, Java, component. Really? 1 second. Okay, this is the JDK. Okay, I'm just setting up the JDK. All right. Okay, and I can write the code here.
It's kind of slow.
Yeah, it might look slow, but again I'm saying that it's a perspective. If you like JetBrains tools, you will hate Eclipse. If you like Eclipse a lot, you will hate JetBrains. So you can pick and choose sides, but do you think really a tool would survive when a powerful tool like Eclipse stayed for many years? This survived for many years, this tool. There is something in it. Agree? So it's not like a big company like Microsoft supporting it, right? Agree? It's a small company, and still this tool survived for many years. So you can see that there is something good about it. All right, so I will say hello world. So you can say like it created template for me automatically, and I'm just saying hello world. Agree? And if you run this, you can see it is printing hello world. So you can do the same thing with Eclipse. We'll do with IntelliJ this batch. So let's see how it goes. So if you hate it, do it in Eclipse. No, you should try and experiment yourself. You can go even for NetBeans. You can go for whatever it is. Agree? At least nowadays, even for JavaScript, we don't even have to download anything. We can write in a website only, like JS Fiddle and everything like that. For example, let me show. for JavaScript and other things nowadays, like Cloud9. Development environment in the cloud. Okay, so I think you need to create an account. Try Cloud9. Okay, you can connect to GitHub and sign up for. Okay, authorize application. Okay. Okay. So you can say you want a PHP application. I don't think there is Java there. Okay. There is no Java, but there is C++ there. Okay, for example, open project or something. So you can even do, nowadays people can do everything on the web application directly itself. No need for download anything. Code it in cloud, connect to GitHub, connect to directly run it from there or anything. So I just want to show you how where editors are moving forward. Agree? See Python, Ruby, Node.js, HTML, everything is here. Okay. All right.